So the way this is going to work is it's a single answer question. So the question is, what kind of professional background does everyone on the line have? Do you come from more of a GIS background? Are you more on the database side? Is it more general IT? Or is it something totally different from that? So if everyone could kindly select your answers, just the best one that fits your background. I want to get a good feel for what our audience currently is in, and we will kick things off. I see we have a lot of people on the database side of the house and also general IT. You're good to go. We will give people one more minute. Database and IT are neck and neck. Okay, thank you so much for your answers. We will move on. Adam, do you have any comments about this?
No, the poll looks good. That's about what I was expecting. A lot of people with database background, I assume you're wanting to get started with PostGIS, and a few with GIS. Yeah, so more database, more general IT. That's about what we were expecting, but I think this will be a good webinar for all. So we're ready to get started.
Good, and I will turn things over to you and go from there.
All right, thanks, Christina. Here one, sorry, I skipped ahead in the slide here. All right, thanks, Christina, and hello, everyone. Welcome to the webinar, Getting Started with PostGIS. My name is Adam Wright. I'm a database consultant here at Enterprise DB. That means I'm out there in the trenches, working with customers, helping them architect and scale their Postgres environment, and also help deploy EDB tools for managing and monitoring fleets of Postgres servers in corporate environments. I began working on GIS systems at a national mapping agency straight out of college. That was back in the early 2000s with ArcInfo on the desktop, and then ArcIMS for displaying shapefiles over the web. And then later I began working with spatial databases in the private sector, both Oracle Spatial and PostGIS. And it's still amazing to me how many powerful things you can do with just a little bit of SQL when your GIS is integrated right into the database. So like Postgres, PostGIS is pretty easy to set up and get running. At Enterprise DB, we get contacted by a lot of people, companies, saying, hey, we have this business database, and now we need to do some spatial analysis. You know, where do we even get started? And hopefully this webinar helps so you can get started and take advantage of this powerful system. So in this webinar, the agenda for today, we're going to give an introduction to Enterprise DB, who we are, what we do, talk a little bit about Postgres and why it's important in the context of PostGIS. I'll give an overview of PostGIS. We'll cover some geospatial basics that you'll need to get started. And then we'll talk about database maintenance when you have to support PostGIS as a DBA. All right, so Enterprise DB. Enterprise DB, we provide support, training services around open source Postgres. We have a number of Postgres community developers, including members of the core team. We also have our own EDB Postgres Plus Advanced server, which is the open source Postgres with features added on top that are requested by enterprises. Features like Resource Manager, profiles, which are coming in 9.5, declarative partitioning syntax, and an Oracle compatibility layer that provides a ton of features in itself. But it also makes it easier and faster to migrate your Oracle database to a Postgres-based system. EDB also offers monitoring tools for Postgres, and there is the Enterprise DB Migration Toolkit that helps migrate from other database platforms to Postgres. And we also have an XDB replication server that's really cool. It helps replicate data from other database servers like Oracle and SQL Server to Postgres. And you can also go any other direction if that suits your needs. And we also provide support and services for Postgres and PostGIS. And be on the lookout. We have a PostGIS live virtual training that's going to be coming soon. So a little bit about Postgres. Because when you're using Postgres, you can also leverage the power of the underlying database system it's built upon. Postgres is fully ACID compliant database server. In order for a commit to be successful, it must persist on disk. With Postgres, you can pull the power in your system, and Postgres will come back up and auto-recover itself. You can have multiple users. Readers won't block writers. Writers won't block readers. Postgres supports a wide range of indexes, index types, triggers, views, materialized views, table partitioning via inheritance, support for JSON, JSON-B, 9.4, HStore. We've tested linear scalability beyond 64 cores. And important for GIS developers is grouping, cube, and rollup coming in 9.5. Those three are also available today in EDB Postgres Plus. And Postgres was designed from the very beginning to allow runtime extensions. They're treated as first-class citizens inside of the database. This diagram here, this is a very typical setup that we see at a lot of customer sites. So like Postgres is mature, it's high-quality open-source software, it's free to use, so you can easily scale out your system, like this diagram shows. Unlike other spatial extensions, pay up to $40,000 a core to just enable it. You can add a primary server, then you could replicate to a standby server, and then to another standby server. That standby server can be in the same rack. It can be at a regional site, and then you can use a replication-aware connection pooler like PG Pool and route all the writes to the primary and all the reads to the standby server. This helps scale reads. It also helps with writes by reducing the workload on the primary server. We can also add in a tool like Enterprise DB Failover Manager, which will automatically promote this standby to primary if there's a failure on the primary server. That's just showing you how you could scale out your environment easy and in a very cost-effective way. About PostGIS. PostGIS has been around for almost 15 years now. It was first released by Refractions Research 2001, and it was released under the GNU license. It's open source software. Install it anywhere you like at no charge. You can get support from companies like Enterprise DB as part of the Postgres support package. Most Postgres platform as a service offerings, or all that I'm aware of, offer PostGIS as an extension. For example, if you're on Amazon Web Services and using EDB's Postgres Plus Cloud database, you can easily turn on PostGIS. You don't even have to worry about much going on behind the scenes. And PostGIS follows the simple features for SQL specification from the OGC. If you're coming from another spatial database like Oracle Spatial or Microsoft SQL Server 2008 and above, there may be some familiarity there. And there are over 300 spatial operators and functions. We can do simple things like convert text to geometries, but we can also do powerful analytics like join our customer data with demographic data based on location. And with that, we can do micro-advertising. If you're involved in the 2016 elections, you can use a spatial database to do micro-targeting mailers. Which sort of political messages you get can be based on the characteristics of your neighborhood, past voting results, income, number of family members. If a wildfire breaks out, we can write a simple query to identify all the houses within a given radius. Postgres supports a lot of different spatial data types, geometry for flat Earth, geography for round Earth, all the classic subtypes you would expect, points, lines, polygons, and topology types if your geographic features are connected, related. So in the case of a topology type, you move one polygon and it moves another. Shifting one parcel shifts the other parcel which touches it. Creating a spatial index is simple in Postgres. We just issue the standard syntax. All the tools you use to during your regular database maintenance. Create index name on table name using gist, and then geometry column name. Very simple to issue that command. You can perform a coordinate reprojection as part of a query using ST transform, so spatial reprojection on the fly. Importing Esri shapefiles can be done at the command line using shape to PGSQL, which should be in your Postgres bin directory after you install PostGIS. There's also a shape to PGSQL GUI loader. The GDAL library has OGR to OGR, which has support for shapefiles to and from PostGIS, along with a number of other different data formats. And just as there is shape to PGSQL, there is also raster to PGSQL for loading raster files to a table with the spatial data type raster. There are a number of different input and output functions. Getting a geometry to and from well-known text, KML, GML. One that's really hot right now is GeoJSON. So we can take a geometry and display it as GeoJSON. If you're using something like OpenLayers, you have a JavaScript API, you can paint it on a map with GeoJSON, and you can go the other way, input, output. So that's just a high-level overview about PostGIS. We'll dig a little deeper here. All right, PostGIS data types. PostGIS supports a number of data types. These are the most common. And the most commonly used of these data types is geometry. It uses a Cartesian grid. All geometry subtypes, points, lines, polygons, they all assume a Cartesian coordinate system when you're using the geometry type. Compared to the round earth geography type, geometry has more functions. Many times relationship checks can be faster. And geometry type has more support from third-party desktop applications. It's useful when the area you're working with is small enough that the curvature of the Earth doesn't come into play. But if you're dealing with distances on a global scale and have data that covers the poles and crosses the dateline, you'll want to use the geography type in that case. And with Postgres, you can also do cast to, from geography and geometry. Geometry is usually sufficient for local governments, regional data sets. With geography type, data is treated like it's an ellipsoid. Multinational corporations, government agencies, especially defense and intelligence agencies that have global data that covers the poles, crosses state lines, normally use the geometry type, or uses, the geography type. The geography type was more recently added. I believe it was PostGIS 1.5, so there are fewer functions are supported. But again, you can use ST transform to cast to and from geography and geometry. There's some overhead involved with casting on the fly or reprojecting your data on the fly. Topology, this is a relational model type. A topology expresses spatial relationships between connecting or adjacent vector features, points, lines, polygons. PostGIS provides a network topology model that ensures that when you change the edge of an object, other objects sharing that edge will change accordingly. A classic GIS example of a topology is a subway map. If you're traveling around the city, you have to find trains that connect you from your source location and destination. You have a train route, and that's stored as a line string. But you also need station information, maybe a point, and metadata about where to change trains at. Parcels is another commonly used usage of topology type. Raster data, the three data types we previously mentioned, geometry, geography, topology, those are all vector features. The other data type to mention here is raster. Rasters are made up of a matrix of pixels or cells. With each pixel contains a value that represents the conditions for the area covered by the cell. Raster data can be used as a base layer or a backdrop behind vector layers, and it provides more context and more meaning to the vector information. Similarly, when you turn on Earth in Google Map, it usually gives you a little bit more context. Laying a vector layer on top of the image, it's usually just much more easier for a human to interpret if you're just doing visual analysis. But raster data can also be used for more automated analysis. You can show the risk of a fire in a given edge. If you just simplified a vector feature, you can use a lot of detail. But in this case, with the raster data, each cell in the raster can represent a different value, just continually varying information, pixel to pixel. Rasters can be used to model hydrography data sets over the land surface, used to calculate where watershed and stream networks exist based on the terrain. It's also very commonly used in crop yield analysis, so each cell displaying varying yield information. In a lot of these, if you need more information, the PostGIS documentation is really good. And like I had mentioned earlier, we do have a live virtual training that's going to be coming up soon. Those were the PostGIS data types. And so this slide here shows the PostGIS data subtypes. These are the classic PostGIS data subtypes. A point is a spatial type that represents a single location on Earth, which is represented by a coordinate. You can use points when the shape and size of your data is not important. Your point in the database contains a lat-long value, and you can actually add a z value for height or elevation. A classic point is just a set of x and y values. If you're using a spatial database, you may want to store a point in a polygon for a feature without calculating the centroid each time. So you may have like a city boundary, but you also want a point on that boundary if you don't need the overhead of storing that polygon. You're using a database, so you can just add a spatial column for each of your business table, or you can do a more normalized approach and use separate tables to house the geometry. You're using a database, so you can just simply join to that data when you need to. Multi-point, just a collection of points. Line string, connected straight line by two or more distinct points. The individual lines between the points are called segments, and each line segment defines a straight line. Examples of a line string: roads, rivers, flight path, walking paths, or walking routes. Those have become more popular. It seems to be a lot of mobile apps using different walking routes, such as health and fitness. Multi-string, as you might guess, multi-string is just used to represent a collection of line strings. Polygon features are enclosed area like a political boundary. The first and last vertices should always be at the same place. That's how they're enclosed. Again, political boundaries, sales territories. Multi-polygon, a collection of polygons. This may be a political boundary, which may have an enclosed area that does not touch, like a state with islands, Rhode Island, Massachusetts, or even a city with a river or lake that has a landmass in the middle, or just any unique collection of polygons. And PostGIS does support Z and even M values as well. All right, some spatial definitions here. The first one we'll talk about, these are the common spatial definitions examples. This one is a boundary. We draw a boundary. This can be a political boundary, arbitrary, rule-based, human-generated boundary system using your desktop application or WebGIS. And an item either falls inside or outside of the boundary. Contamination zone, school zone. Buffer. This is very commonly used in GIS. We take geometry and we expand it. The ST buffer function can be used to expand by a specified number of units. The distance can also be negative, the ST buffer. If you provide a negative radius, you buffer the polygon or shrink the polygon rather than expand it. If you're trying to do a radius search, you can compare, with other functions like the ST D within function. It may be more efficient you're using Postgres, so you can do explain plans and see which one performs better. An example of doing buffer is that maybe you have a city and you have a point that represents that city, and you can expand within a 1 mile buffer the downtown and tell where the number of ATMs or bars are at. How many bars do we have within 1 mile of downtown? If you're in the fast food business, tell me the number of fast food restaurants within 1 mile of each exit ramp. Contained, this is when one spatial object contains another spatial object. The interior includes all points of the other objects. If an object such as a point or line string only exists along the polygon's boundary, the polygon does not contain it. If a point is on a line string, the line string contains it. You can get all of the different rules, postgis.net/doc/stcontains.html. You need to follow up on that one. Equals. So this is in this case is a bounding box equality. In the database world, you're used to equal when you write queries. You use the equal sign, return true, or return row, where some attribute equals a given number or a string. Postgres spatial equal is better than a simple equal. Spatially equal allows the ordering of points to be different, but represent the same geometry structure. If you're using the st equals function, a simple st equal means that the two geometries occupy the same space and have the same underlying representation. If you use st ordering equals, if you need to verify that the points are actually consistent, so it's a little bit more stringent in that it verifies the ordering of points are the same. For the simple st equals, an example of that would be your commute route to and work is spatially equal. Slide here. Intersection. The concept of a spatial intersection is simply when geometries have 2 points in common. The st intersection, an example of that could be if you're putting a GPS unit on a hazmat truck, and later on you go and plot its route, and then you discover that the hazmat truck crossed into an urban area where hazmat trucks aren't allowed. There's the st intersection function in PostGIS. You can also try using st distance within, used for that as well. So that's just an overview of some common geospatial concepts. But if you're a DBA and you're managing a business database today, you have a well-planned system architecture, your high availability is set up, your backups are going good, you have monitoring in place, and then one day your boss comes to you and says, hey, we need to start doing some spatial analysis with the data we have. You need to do this with a competitive edge, for a competitive edge to keep up. We'll need to import some spatial data. We need to create some spatial data. So how do we even get started setting up PostGIS? Obviously, we'll need to install PostGIS. There are different ways to install it. If you're using Red Hat, you can just do a yum install PostGIS 294. And in this case, we're using the official PostGIS repos. For that example there, you would have to have the EPEL repository to resolve some dependencies that PostGIS relies on. Debian repositories do an apt-get. Enterprise DB also includes, if you're not familiar, this is the binary installer. One of the cool things about the binary installer is that it works on Linux, it works on Windows, and it works on Mac. You can install Postgres using the binary installers. This extra utility for managing packages around Postgres will pop up, or you can launch it separately. It's called Stack Builder, and then under Spatial Extensions, you would just check PostGIS, next, and that would come along. And then the binary installer, another thing that allows you to do if you're in a defense agency and your data can't be online, then you could grab the binary using Stack Builder on a separate system, put it on a USB key or any other method to get that data to your isolated PostGIS server. That's an advantage of using the binary installer there. All right, so we have PostGIS installed, all the dependencies are installed, the binaries are installed. Now we need to enable PostGIS on our Postgres database. How do we do this? Well, if we have an existing database and we need to spatially enable it, we can just do create extension PostGIS. If we need to use PostGIS topology, we can optionally use the create extension PostGIS topology. If we're creating a new database, when we install PostGIS, we'll get this template database named template_PostGIS. That has the PostGIS extension already created. So we just do create database. In this example, my database name is GODB with template equal template PostGIS, and then any other options that you would normally use in your create database statement. That one right there would run your default database. And then afterwards, we need to verify PostGIS is installed. We just run this PostGIS version function, select PostGIS version. And what you'll see when you run that, it's very similar to select Postgres version function. If you use that, syntax is the same. That's going to show you the PostGIS version that's installed. And then you're also going to see a couple of different libraries that Postgres relies on. The two common ones are proj4 and GIS. Coordinate geometries and relationships between geometries comes from the open source GIS libraries, and then proj4 will handle map projections. All right, so we installed PostGIS, we enabled it in our existing database, we created another database. If you're not familiar, extensions are enabled by database. Postgres is installed, we're good to go. Now we need to load some data. Loading data is not a big task here with PostGIS. If we need to load Esri shape files, we can use the shape to PGSQL binary that's included. You'll find it in the PostgreSQL bin directory after the installation. So we can do this on the database server. We can issue this command, or we could run this on our local machine and just point to a different host. So we do shape to PGSQL, and there's a bunch of different options. If you want to see them all with a brief description, you can just simply type shape to PGSQL -H, and that'll show you the help. So in this example, we're doing shape to PGSQL -C. So this means we're going to create a new table. We're doing -S, and we're going to use, in this example, we're going to use 4629 as our spatial reference ID. This data is all local, so we're going to use that North American datum here, just because it's all local. And then our shape file is named Boston, Massachusetts OSM line shape. This is OpenStreetMap lines that I downloaded on the internet. So, and then we take that data, so we're using shape to PGSQL, and we're going to pipe that to PSQL. And then -D is my database name. In this example, when I ran this, I was doing it all on the local machine, so I didn't need to put the local host. If you're doing this on a remote machine, just hyphen your standard PSQL commands, -H, and then the name of the database server. Optionally, include port and username if you need to. So that will load our shape file into a newly created table. And then if I just need to insert a point, say I already have a cities table, but I don't have any spatial representation in the database, we can just use standard SQL. So in this case, do insert into cities, name attribute, state attribute, and then geometry. Values, Boston name, Massachusetts is the state, and we're going to create a point from text. So we're going to use the ST geometry from text, one of our input functions we can use. We give it the long lat, and then in this case, we're using 4326 for GS84. We have cities all over the globe. And then over on the right-hand side, that map is just very simple. I just did that with QGIS, and I loaded the lines for Boston, and then added the one row I had in the cities table, and added and included a label with QGIS. Optionally, with Shape to PGSQL, and in this example, I created a new table. That's not necessarily. You could optionally append to an existing table, include and exclude attributes that you need. Another situation you may run into is maybe you have an events table already, or you have any table, and in the events table, you have an event name, just standard database attributes, bar char, you have a lat that you're storing, you have a long that you're storing, and then you have a date. But now you need to do more with that. So you create an events geotable. Optionally, you could also add a geometry column. There's an add geometry column function you could use and add it to the events table. In this case, we're just going to simply create a new events geotable. We give it the events name, we give it a geometry, and then we give it a date. And then we're just going to insert into events geo, select event name, set SRID, because we don't have an SRID on this data. It's just simply text. And then we're going to use the stMakePoint function. That's all that's going on here. We're taking two data points as text, and then we're just turning those into a geometry point, passing the long lat, and then as geometry, and then date from the events table. This is also very common. With GIS systems, there's a lot of quality control that usually goes on. I see a lot of cases where we use a staging table very similarly. So we load the data into a staging table. We can project it on the fly, and then when the data is, when the quality control person says, "Yep, at this point's good. It doesn't fall in the ocean. The attributes are good," and then we have a process that actually loads it into our events geo table. It's another use case. Yes, so when you need to do a visual inspection, there are a lot of different ways to do this. You can use WebGIS. OpenGeo has options. You have GeoServer, MapServer, OpenLayers. Then there's also a lot of desktop GIS options. QGIS, UDIG, OpenJump. This one here is just QGIS. Nothing crazy going on here. I simply added a PostGIS database connection and then added the OpenStreetMap lines as a layer. You'll hear, if you're coming from the database world and you keep hearing layer, layers just simply, you can just relate it to a table. GIS people like to call it a layer. So we added the OpenStreetMap line table. It's a layer here in QGIS. And I just used the default options here. So it painted the roads as red. There's a lot more we could have done. So we're doing a visual inspection. Lines aren't crossing over. I'm familiar with the area. This looks like I was expecting it to look like. So more on the visual inspection of data. So in this case, I had a cardinal boundary of the United States. This data was downloaded from Census. And then I put the OpenStreetMap lines on top of the map. So I know, so my cartographic boundaries of the U.S. states, I've already QA'd this data. I know that it's good spatially. So now I took this other data and I laid it on top, and yep, it's being projected correctly where I expect it to be. It's not off in the ocean somewhere. That's the boundary I was expecting. So you can have different inspections of data, different methods for it. One of the nice ones I've used in the past is just having a web map service where we do that visual inspection, and then you have a box, you check it, it's good, and then that data actually gets loaded into your production database. Or you can just use your simple desktop GIS application if you'd like. The input and output functions that I mentioned earlier, Here's an example of it. Select ST as text, so we're taking our geometry binary and just displaying it as text. We can also do that as ST as GeoJSON, ST as GML. And in this case, I have a table that shows me the ATM locations. So I'm just outputting that as different methods, maybe different systems you want to feed into. So here we're getting our geometry data as different types. Input-output function again, creating a geometry type from text. This case is Enterprise DB headquarters. I'm just going to insert into cities, Bedford, Massachusetts, ST, geometry from text. I can just feed that in. If you have users in your organization that need to just add dynamically, need to add spatial data, you could just have a web service. You could have a database function that you call, a form, and then just create a PGSQL function. Easy as that. So we do all this visual inspection. We're using GIS sort of in a classic sense. One thing that's really cool is just combining the power of GIS and SQL. And one of the things that makes it so cool is we can do very powerful things with just a little bit of SQL. So in this first example here, this is just a function that I wrote, and it's going to create a point radius ring. Very simple. We're using the ST distance within PostGIS function. And what it's doing is creating a point radius ring and determining whether that point falls within that ring. We're going to return 1, or else we're going to return 0. We can create a collection of waypoints that were captured in a sequence. So we're just going to use some SQL here. We're going to create table paths. So we're going to turn a collection of waypoints into lines in the database. So create table paths as selecting our route ID, our sequence, and our geometry from this waypoints table. And then we're going to group that, order it by sequence, and group by the route ID. So this would turn our waypoints. Just think maybe map my walk here, or if you had a GPS application and along that route, it is going in, you're just collecting different waypoints around the way, and now you want to turn that into a line string. That's just a line of SQL, where you can do that too. This is just a visualization of that. So all we're doing here, we're not even using data that's stored in the database. We're just doing a simple distance query between 2 points. Select ST distance, geometry from text that I'm providing. So you could create a web map service, have a function that takes this as an input, and give you the distance between 2 points. You could draw this dynamically using something, a desktop application like QGIS. I went back in the slides there, my apologies. And then this, I'm showing the Power GIS in SQL here. So this is in the QGIS application. I could dynamically create an SQL. So this is selecting my geometry from ATM locations. This is the ATM locations table stored in the database. And return all geometries where a primary road, or where this Navy Federal Credit Union is, within 1 mile of a primary road. So maybe we want to analyze, where we have a gap in ATMs, or do some competitive analysis. So we can generate a report if we're just using an SQL, but if we're using a GIS application or WebGIS, then we'll actually get a visual of this. Sometimes that can be much more powerful, tell a bigger story. So in this case, we can see here, we have our county boundary, our cartographic boundary of the U.S. states. We have all of our roads, and then we have all of the Navy Federal Credit Unions that fall within 1 mile of a primary road. That's just sort of a taste of the things you can do with just a little bit of SQL in the database and PostGIS. Maintenance of a PostGIS database. We had a lot of database administrators on the line. Managing a PostGIS database is no different than you would just a normal database. There are a few other considerations. You may do a lot of bulk inserts or bulk updates with PostGIS. That seems to be very common. Hey, we got a new collection of data. We got a roads update. So a lot of bulk inserts, updates. Just remember when you're doing that process, no different than doing a bulk data load in the other way to run a vacuum analyze afterwards. If you're loading large data sets, you can load that data set or doing an initial load. We can load that data set and then build the indexes after. That may be faster in some cases. Using an explain plan, so you set up this new process, you're messing around with SQL, you're messing around with PostGIS functions. PostGIS is baked right into the query planner, takes advantage of the query planner in Postgres. So using an explain plan when you're writing new queries. Add indexes on PostGIS columns. Again, that's just the standard Postgres syntax you would normally use. Backup, recovery, and stream and replication considerations. You can take a PG dump of a Postgres database with PostGIS on it, restore it somewhere else, but what you have to remember is to install the same version of Postgres and the same version of PostGIS on the other side. And stream and replication considerations. The same thing, make sure that when you're primary and standby server, when you're replicating to those, that you also have the same version of Postgres and the same version of PostGIS installed on both sides. Other than that, your backup processes, stream and replication will all be about the same. No real difference there. So some notes. The power of Postgres, we can use PostGIS on top of Postgres, and we can take advantage of all the things that Postgres has: binary replication, table partitioning, text searches, text functions, operators. We have PLSQL, PL-Python, JSON, or JavaScript developers out there. You can write with PLV8. There's PLR, indexes for fast searches, business warehouse-like queries, so grouping sets, cube, rollup. Those are available in EDB Postgres Plus now. They'll also be available in Postgres 9.5 coming later this fall. Foreign table inheritance. So we can do table partitioning now, breaking up these big data sets into smaller, more manageable pieces. But then with foreign table inheritance, aka sharding, we can even go as far as, okay, now my child partition is actually on a different server. OGR to OGR is part of the GDAL library. That includes a lot of tools for getting data back and forth between different database systems, different data formats. If you need to build web maps, open layers, map server, GeoServer, all of those are compatible or use PostGIS, can leverage PostGIS. Some additional resources. If you need to dig into more of the GIS concepts as opposed to the database system, there's a really good book, PostGIS in Action, you can find online. So this, if you want to learn about coordinate systems and really dive deep into this stuff, PostGIS in Action is an excellent book. Enterprise DB, we provide professional services. We'll help you with your Postgres environment. We'll help you with your PostGIS installation. We'll help migrate you from other database platforms to Postgres. And coming soon, we have a PostGIS live virtual training. So be on the lookout for that. And, of course, the official docs, like Postgres has, the community has excellent documentation, so does the PostGIS community. So this is really going to cover, okay, I really want to know what ST contains is, what the rules are for that. That's where you'd really want to reference the PostGIS docs. All right, so that's everything from this morning. I think we'll cover questions now.
Yes, thank you very much, Adam, for that presentation. We did have some questions come in while you were speaking. The first question was, can rasters be stored outside of the database?
Yeah, the short answer to that is yes. If you're doing analysis, that could be slightly slower, but if you are just taking rasters, terabytes of rasters, and you're just shoving them into the database, with no other purpose than yanking them back out to view them on a map, then storing them outside the database will probably be a better idea. I believe it's the -R option. So if you do raster to PGSQL, there's a -H option, which that should give you the right switch for that.
Great. Another question is PostGIS supported on Windows?
Yes, it is supported on Windows. In that case, I would use the Enterprise DB installer. It would stack build it. It'll make the installation and compilation a lot easier in that case.
Great. Another question is, are there GIS desktop applications?
Yeah. So there are a lot of open source desktop applications that you can use with PostGIS. The one I was using in the examples there was when I prefer QGIS. There are a lot of others, UDIG, OpenJump, are just a couple commercial tools started supporting PostGIS. PostGIS is wildly popular now. We're doing GIS work, so I'm trying to think of commercial database or commercial GIS applications that don't support PostGIS. Even Esri sort of had to come to the party. You can use query layers to use PostGIS. You can also use their ArcSD extension and use the PostGIS geometry type, mixing that up if you needed to do any sort of large-scale, global cartography.
Another question is, does PostGIS work with streaming replication? Yeah. So the only thing to be careful of there when you're using streaming replication is making sure that you have the same version of Postgres on both sides and that you have the same version of PostGIS installed on both sides. I would just use whatever method you used on one side to do the installation. I would use the same method on the other side to make sure you have the same, that way you have the same GDAL libraries, same GEOS libraries, same Proj4 libraries, and the same version of PostGIS on the other side. Great. Another question is, how do you allow client access to a PG database on a remote server?
Yeah, so for PostGIS, it's not much different than just your normal Postgres database. So when you install Postgres inside of your data directory, you're going to have a host-based access file, so that's your PGHBA, and that's where you define firewall rules. So you can open it up to simple, just your web server. You can open up Postgres to, your entire subnet or to the world, whatever your use case is. So you just need to put those rules in place in your PGHBA, do a PGCTL reload of the comp, and that will reload your PGHBA configurations. And then when your client's trying to connect, the default port for Postgres is 5432. The default port for EDB Postgres Plus is 5444. So then when your client goes to connect, it's just like making any other database connection or any other Postgres connection. You're going to just point to that host name, give it the right port number. And then one thing to make sure is that in your PostgreSQL comp to your listening connections or listening, your listen addresses are listening on the right NIC, with the right IP address on your server.
Great.
So it's pretty standard. And then with using something like QGIS, it's going to only when you add a database, you can just filter on only your spatial tables. So when you go to load that, the only thing you'll see in your database connections, optionally, the right box checked, is your spatially enabled tables.
another question that came in is, can you explain what a shapefile contains?
Yep. So a shapefile used to be, before, it used to be a way, just to pass flat files around, and it was really inefficient. So you had a shapefile, you worked on your desktop application, and then, you may put it on a file server and an NFS share, and pass it along. Your updates aren't going to be seen until you load that back in your desktop application. There's a couple of mandatory files that a shapefile has. There's the .shp. So when you go to load a shapefile, you'll see at least 3 files. You may see a number more, but you'll at least see the .shp file, and that's the shape format. So that's the actual geometry features themselves in the .shape file. There's an SHX file, and that is the shape index format. And then you'll also see DBF, so that's the attribute format. You can think of like a Microsoft Access file. It's a .dbf file. And a lot of the tools that you're using, you can load just the DBF, so you can get the attribute information, or you can exclude certain attributes. You can use OGR to map those properly to your attributes. And there's a few other files, the important one being the PRJ file, and that's it contains the coordinate system and projection information. And then you could use tools to reproject it as you load it into your data if it doesn't match. There's a number of other files, but the 3 mandatory files are the SHP, SHX, DBF, and then when you're using a tool like Shape2, when you're using a tool like QGIS or Shape2PGSQL, you would just point at the .shp file.
Great, thank you. Can you explain what the process might look like for doing an offline install?
Yeah, an offline installation. So if you don't want to use the repos, then you could use the binary installation. I'm sure there are different other ways to do it. The best way I would do it, or the best way I can think of, is to take a system that's like the one you have, so if it's your development system, and then you could get the binaries. So with like Stack Builder, so you would install Postgres, install Stack Builder, pull down on the separate system, you'll pull down those binaries, and then you can move those to your disconnected database server, and then do the manual installation from there. You'll get a .bin file, so you get a binary file, do // and you can install it from there.
Great. Another question that came in, can you aim and replicate Postgres database using a work line, or should you need the Lisa line to replicate?
Sorry, I didn't quite get that one, but can you say that one more time?
You replicate Postgres database using a public network, or do you need to use a lease line to replicate?
Just using if I understand the question right, and if it's not, just put it in the chat and we'll follow up if I'm not answering correctly. The way I understand it is the way you do string replication between 2 Postgres database servers. You just need a TCP connection to be open between the 2. So that could be a replication that's in the same rack on your same private network. That can actually be, you just need a TCP link between those 2. You could use, that could be your headquarters office replicating to your regional office. And that could also be, we see a lot of cases now, it seems to become popular, that, hey, our primary database that supports our internal office is, on-site, on-premise, but then we're also replicating to Amazon Web Services as our disaster recovery site. You just need a connection. You just need those two ports to be open between the two. Just to clarify, so that's the streaming replication that's built into the community Postgres, the open source Postgres. You can really download and install. You can get support from Enterprise DB for that, to replicate between those two.
Great. Another question that came in, can you explain how PostGIS enables vector filing for web maps?
For how PostGIS enables vectoring files for web maps? That's a little bit broad. I do a little bit of research on that. We can follow up on more detail as well. But you can just do standard connections. Most of the app servers that support like SPES binary will connect to Postgres, and you could use something like a standard OGC web map service with map server and display those tiles, those web map services over just a standard connection. You can also use something like OpenLayers and export as GeoJSON if you'd like to. Whoever asked that question, if you put a little more detail in the chat, be sure to follow up with a more complete answer later.
Great. And another question that came in is there any best practice for storing loads of data properly?
For storing loads of data properly? Yeah, I would. It's going to depend on each use case, right? If you have a really large table, no differently than storing, lots of standard database attributes in one table, you may want to break that up with partitioning, on something that has a good key for putting your where clause to break it into smaller pieces. If it's raster data, you may want to consider storing it outside of the database instead of unnecessarily shoving terabytes of raster data into the database, even though Postgres can handle it. That's going to depend on your data. But if you're to contact Enterprise DB, I'd be happy to follow up on that in more detail.
Okay, great. Thank you so much for that, Adam. That actually brings us to the end of the webinar.